Okay, this is mechanics. You have 3.1 to 3.5 as well as these two grids. Listen, people are still ignoring these two grid questions that are in the material. They were in the material last week and the week before and the week before that for both physics and mechanics, and they come copy paste as the course revision. Please do them, please do them, please do them. Maybe 3 times I said, please do them. That's the fourth time. Guys, do it. Wallah, please, please do it. Like, they're coming copy paste. People are getting the whole exam correct except these. And ولو يعني they're in the course division copy paste. uh I think this time he actually put them in the quiz عشان لاحظ انه people are actually skipping them from the course division. uh على كل الأحوال anyways, please do them. If they're here in your material, go course division. It will take you 2 minutes maybe. Here you go page عندي شو questions أي solution. تروح على page مكتوب الماتيريال 7. بتروح for free fall you question 26. بتروح على الجواب الانسر هي هون. memorize it. وكمان عندك شو هون study the motion of projectiles page 9. نروح على page 9 هي question 2 مثل ما هي ما بدها هالقد really. okay please do them. anyway 3.1 to 3.5 very easy كله forces وكل شيء هاد chapters. I'm gonna skip over the yap. Please read over it yourself if you want. But I'm gonna just get straight to the point, things that need explanations. حاولوا يحفظون. These are all stuff يعني from previous years. Yeah, FAB is force exerted by A on B. It's opposite to BA. Newton's third law, you don't need this, but you know it. You need this for next week though. Okay, this comes every week, every exam, sorry. There are three properties of a force that affects its motion. A force can have a direction. A force can have a point of application. Where are you applying the force? And the magnitude of a force. And the magnitude is composed of a number and a unit. You can't just say 6. You have to 6 newtons, right? Two types of forces: contact, non-contact. La 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 la. Non-contact forces are also known as forces at a distance, long-range forces, field force, whatever. Okay, spring force is the force exerted by a spring when compressed or stretched. Okay, it's a restoring force that tends to bring the spring back to its natural length. Until when you pull a spring out, you stretch it out, you let go, the spring goes back to its normal length. The equilibrium position is the position of the spring when the forces are balanced. So when it's like back here, okay. The ideal spring is one in which the elongation is directly la 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 la. You have this formula, you need to memorize it. The force is equal to minus kx, where k is the coefficient of linear expansion given in the question, and x is what did I say? K was k no, k is the spring constant. What did I say now? X is displacement or elongation in meters. Okay, it has to be in meters, no? Okay, why is it negative? Because the direction of the restoring force is opposite to that of the elongation. Until you put it to the right, the restoring force will pull it to the left, right? You want to restore it. When a spring exceeds its limit, it deforms and stops obeying Hooke's law. Okay, la 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 la. This is just how the graph looks if they ask. Tension is a pulling force exerted. Okay, you need to know this. What is tension? It's a pulling force exerted by strings, ropes used to lift heavy loads. By the way, solve the grids even that are not required, but the grids for 3.1 to 3.5. يعني مثلا نروح ننزل لي هون هيدي مثلا. اوكي وهيدي. This one I think it will come by the way. That's pretty much it. These two يعني they will take you maybe 2 minutes, really 2 minutes, like بالمعنى 2 minutes. Please don't forget to solve them. Okay, open. Please don't be lazy, guys. It will take you maybe 2 minutes just to open the document and solve. Wallah. Let me continue. Yeah, tension is a pulling force used by ropes. Anytime you see a rope, there's tension. It's used to lift heavy loads, denoted by T. Okay, this is Gmo. Actually, this is actually I solved it here. This one, number 1, solved it in the copybook. Weight depends on the gravitational strength. Since on the moon they were asking, do you expect the weight to be the same on the moon as the Earth? أكيد the G of moon is G of Earth, so that means it will have less weight. Okay, whatever. Normal push. This is very important. Any object placed on a surface falls under a reaction force that has two components: the normal force and the friction force. نسولنا الفriction force هلا. Let's talk about the normal force. Okay, بس friction force, this can come multiple choice. Normal force, friction force. The friction force is the reaction of the surface which pulls it to opposite direction. It's the horizontal component. Okay, and the normal force is the reaction of the surface upwards in the perpendicular direction. From the word normal, normal name perpendicular. Okay, friction exists in the case of a rough surface. All surfaces are pretty much rough. Okay, the drag. Okay, drag is the force exerted by air or any fluid on bodies moving in the medium or in that material. In air, what do we call it? Air resistance. What does drag depend on? أكيد on the shape, the size, and the speed, and if it's in a fluid, viscosity. Okay, أكيد shape. If you shape it in like how can I say, a smooth flowing shape, then there will be less air resistance. If it's huge, has higher surface area, then of course there will be more air resistance. If it's moving at a fast speed, I think there will be higher air resistance. Viscosity is basically how thick the liquid is. So مثلا if you place let's say if you shoot a bullet through water and you shoot a bullet through honey, one will be way slower because the viscosity of honey is way higher than that of water. Okay, basically the thickness of the liquid. Okay, هلا non-contact force. There are three non-contact forces in physics or mechanics or whatever. Well, they are magnetic, electric, and gravitational. Okay, these are straightforward. Gravitational is the one exerted by Earth, right? Weight is the gravitational force. It is the downward force exerted by Earth on an object and it's non-contact. Okay, you should know W is equal to mg. Okay, W mg. خلاص guys, this is all stuff. Okay, a force is a vector. In diagrams, it's represented by an arrow, right? Head, tail, whatever. A force has a direction magnitude that can be measured using a spring scale, whatever. Okay, free body diagrams. These are very important. I don't think they asked them in the quiz for some reason, but you should know what a free body diagram is. Basically, you just draw all forces and the direction they're acting. So this is like a trolley being pushed by a woman. The force of the woman on the trolley. You have the weight obviously putting the trolley down, and you have the normal reaction that's opposing the weight. And then you have obviously friction. F. This is small f, but I don't know why the camera didn't really catch the pencil in this case, the scanner. But anyway, a force can be measured using a spring scale. It can always be resolved into components, Fx, Fy, right? If the net force has the same magnitude and direction as the original force, then they will have the same. Okay, well, this is, yeah, well, this is, okay. The principle of superposition of forces is basically meaning that you can add up forces, okay? وكمان you can resolve it into components, Fx and Fy. Cosine for x, sine for y. Then Heidi is just solving questions. La 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 la. Okay. Newton's first law of motion states, okay, the velocity of any object does not change if the net force is zero. Akid, if the net force is zero, then the state of the object will not change. If it's at rest, it will stay at rest. If it's moving, it continues moving at a constant velocity, right? It will not accelerate. So it stays in inertia. Okay, it's called the law of inertia. And basically, sigma f equals zero, basically meaning that the net force, and the sum of all forces acting, is zero. Inertial frame of reference. Okay, this is important because they ask a lot of questions about this. Inertial frame of reference is a frame of reference that is not accelerating with respect to Earth. It can be inertial frame or non-inertial. Okay, let's see. Inertial means it's not accelerating with respect to Earth. For example, a room in a building. A room in a building is not accelerating with respect to Earth. It's not moving. It's just there, right? A non-inertial frame of reference is a frame that is accelerating with respect to Earth. Think about it. Inertia, staying still. Non-inertial is not staying still. Because you know, inertia, the law of inertia states that objects keep their state of motion. What word do we say? Yeah, non-inertial is one that is accelerating with respect to Earth. For example, a decelerating car. Okay, some people will say, oh, it's accelerating, not decelerating. It's the same thing. Okay, it falls under a negative acceleration. Inertia describes a body's resistance to any change in its state of motion so that it maintains a state of constant velocity, including a zero velocity when a body is at rest. Inertia basically means resistance to change in state of motion. So if at rest, it stays at rest. If it's moving, stays moving at that constant velocity. Okay, easy. Okay, Newton's second law. Okay, Newton's second law is basically sum of all forces equal to mass times acceleration. Or in other words, what Newton found was that when he applied different forces across, he got different accelerations, and when he would divide these two forces, he'd get actually the mass of that object. Uh, and this led to two conclusions: the force is directly proportional to the acceleration, and the force is directly proportional to the mass. So F equals ma. Okay, whatever. The graph of FA is a straight line passing through the origin because obviously it's directly proportional. And acceleration is directly proportional to 1 over m. So basically, acceleration is inversely proportional to the mass. So if acceleration increases, that means the mass decreases for the same force, right? So if you double the mass for the same force, what's going to happen? The acceleration will halve. Okay. Mass and weight. Mass is a measure of inertia. It is intrinsic, so it doesn't depend on its location. If you're here or on Earth, the mass will still remain the same. W is equal to ma. In other words, W is equal to mg. And then there's a small note here that the g on the moon is actually equal to 1/6 that of the Earth. Okay, W is mg. W depends on okay. Okay. Let's do the quiz. Which one is a non-inertial frame of reference? Non-inertial, yani it's accelerating. Stationary car, it's not accelerating, right? Train perform uniform rectilinear motion. Is it acceleration? No. URM, there's no acceleration. Book resting, not accelerating. Floor of a playground, not moving. Rotating wheel, yes. صح. It's rotating. Question 2. Okay. The forces act on a body here. What is the algebraic value of the y component of the net force? يعني يمكن بالexam they ask you the x component of the net force. بس يلا let's see. They want Fy net. Okay. So let's resolve this into F1, F2, F3. وبسرعة let's do this. Okay. F1y is equal to F1y plus F2y plus F3y. F1y is equal to 3.2 sine 45. F2y is equal to 2.9 because it's just going down, right? Minus 2.9, sorry. Right? It's going down, so it's negative, but ما في angle, so it's just minus 2.9. If you want to be fancy, you can say sine 270 because 90, 180, 270. You can be fancy, but ما بتستفيد شيء. Okay, minus 2.9. Okay, and it's just going down. It doesn't have an x component. It's going directly down. F3y is equal to, it's going up, so it stays, okay, 4.3 sine 72. Okay, now you take these and you just add them all up. Okay, 3.2 sine 45 minus 2.9 plus 4.3 sine 72. La 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 3.5 Newton. Okay, a cyclist of mass 70 is riding on a bike mass 15, and all of this is accelerating at 0.8 meter per second squared. What is the net force? F is equal to mass times acceleration. What is, they said cyclist and the bike, huh? So it's going to be equal to the mass 15 plus 70 times the acceleration 0.8. Very simple. 15 plus 70 and then times 0.8, you get 68 Newton. Okay, the acceleration of free fall on Mars is 3.7. So G of Mars is 3.7. If the weight of some science equipment on Earth is 250, so weight on Earth is 250. They want the weight on Mars. Okay, actually, you know that the weight on Mars is equal to mass times G of Mars. We need to know the mass, right? Type, okay, W of Earth is equal to M times G of Earth. Okay, you guys should know, if it's not given to you, G of Earth, it was in the book, is 9.8. Okay, So the mass is 250 times شو عم بقول the weight on the earth is 250 equal to the mass times 9.8. We divide now. You're gonna get, let's just say 25.5. So m is equal to 25.5 kg. Now you can go here and substitute with 25.5 times the g of Mars, which is 3.7, and you're gonna get 94.3, 94 newtons. I think, by the way, they use GS10. Let me see if you use GS10. Yeah, no. See, if you use GS10, you're gonna get the wrong answer. You have to use g equals 9.8. If it's not given to you, use g equals 9.8. Okay. Question 5. The tendency of a moving object to carry on moving is called inertia. Anytime you see tendency, especially in this chapter, it's called inertia. Okay, inertia is the tendency to not change state, to carry on moving, right? The physical quantity used to describe this is called mass. Mass is the measure of inertia in an object. Larger objects have larger masses. Therefore, they have larger inertia. Therefore, it's harder for you to get those larger objects to change their state of motion. Question 6. Okay, and the cone. Okay, three forces: the magnitude, the vertical component of the net force, and the horizontal. Okay, guys, that's all very easy. Okay, let's draw it like this. Is the height 37? أكيد هون 53 because they add up to 90. Let's see. They want a vertical component, so Fy net is going to be equal to F. Let's call this F1, F2, F3. So F1y plus F2y plus F3y. F1y is equal to 3 newtons, just 3 because it's going directly upwards. F2y is equal to 5 sine 53. Remember, you have to use the angle that's with the x-axis. You don't use the angle with the y-axis. If you want to use the angle with the y-axis, swap the sine with cosine. 5 sine 53, and then F3y is going directly downwards, so it's going to just be minus 8. Okay, so you should get, let's see here, 3 plus 5 sine 53 minus 8. They said magnitude, so you keep it positive, okay? So Fy net is equal to minus 1.0 Newton. In magnitude, it's 1.0. Magnitude of the horizontal component, Fx net, is equal to F1x plus F2x plus F3x. F1x, does it have any x component? No, 0. F2x, does it have any x component? Yes, 5 cosine 53, right? F3x is 0. So you have to see 5 cosine 53. How much is it? 3.0 to 3.0. What's the magnitude of the net force? The total net force is going to be radical fx squared plus fy squared. صح؟ يلا تعمل radical 1 squared, which is 1 plus 3 squared. You get 3.2. Some people will be confused. Walid, how do you get 0 for fx here? Yeah, I mean, it's going straight down. So it's going straight down. So there's only a vertical component. Horizontal means going left and right. It's not going left and right at all. فاهم أكيد no. Okay, yeah, this is actually the grid question that he put here. Determine experimentally the value of acceleration of free fall. Okay, I doubt it will come like this, but anyway, still know how to do it. Okay. In order to determine experimentally the acceleration of free fall, a student obtains the following graph. It basically shows the change in height over t squared. Okay, you should know that for this one here, we're going to use the formula, the projectile motion formula. Y is equal to minus half gt squared plus v node sine theta t. Just to make things a bit clearer, we're gonna just ignore this, okay? Because he said released from rest, so v node is 0. Okay, and we're just gonna take this part and let's ignore the negative here. We're just gonna take it that the height is equal to half gt squared. Okay, I'm just deriving the formula for you. Just you shouldn't care about what I'm doing now. Just look at the final product. You want to find g, the free fall acceleration. So you you divide by half on the other side, becomes 2 times h, and divide by t squared. So you get, this is your formula you're gonna use for this question. Okay, let's take any points. افترضنا هيدي هون 0.1 0.45. So الهايت 0.45 ف 2 times 0.45 على t squared, so 0.1 squared. لا شو it's already t squared. It's already t squared, so you just keep it على 0.1. Okay, and you get 9 if you put it on your calculator. Okay, easy. رواق. 8. Okay, okay, we'll do this fast. A stone is thrown from the top of a cliff speed with a speed of 15. So phi node is equal to 15. This is the second grid, if I'm not wrong. Yeah, study the motion of projectiles. Okay. At an angle of 30, so theta is equal to 30. The total time is 5. Time total is 5. Use G equals 9 point. Okay. Here, the diagram. What's the initial vertical component? V node Y is equal to V node sine theta, which is equal to 15 sine 30, which is 7.5. How long does it take the stone to reach point Y? Okay. How I did it is I looked at it as one projectile hake, right? This is one projectile motion. So because since it reached the same height it started with, I took it كأنه it was one total flight. I used the formula time total is equal to 2 v node sine theta over g. People use this. Another way to solve is, since you're back at the same point, y equals 0. So 0 is equal to minus half gt squared plus v naught sine theta t, v naught sine theta 7.5. We got part A. OT, let's just take, because you know y is equal to minus half gt squared plus v naught sine theta t. This is the formula. And then you just plug it in. 0 is equal to minus half 9.8 t squared plus 7.5 t. You solve this, you're gonna get t equals 1.5, around 1.5. Come on, this one here, it's way easier in my opinion. It's the same thing, by the way, as this. 2 v naught sine theta, 2 times v naught sine theta, so 7.5 over g 9.8. You're gonna get, come in, around 1.5. What is the height of the cliff edge? Okay. When you reach the bottom of the cliff, you finished your motion. وهن قالوا that the total flight is 5 seconds. ft equals 5, right? طيب هيدي by this time total is different than this is the time total for this here. Okay, anyway, t equals 5. So when it reaches down here, it reaches y is equal to minus h, right? Because how far did it fall down? H meters. But since you're going down, it's minus h. What's the formula for y when you have time g or v naught sine theta? It's this one, right? Minus half gt squared plus v naught sine theta t. So you're gonna substitute y minus h is equal to minus half 9.8 t squared here 5 squared plus v naught sine theta يعني 7.5, because we got part A, v naught sine theta t 5. So you're gonna get, let's do it on our calculator. Minus 0.5 times 9.8 times 5 squared 25 plus 7.5 times 5, you get minus 85. So minus h is equal to minus 85. So h is equal to 85. Question 9. Go through these a bit quicker. Okay. The force on a particle of mass 10 kg varies with time as follows. Okay, where F is in newtons and T is in seconds. Initially, the particle is passing through the origin at 1 meter per second in the positive direction. Select the graph that correctly shows the variation of acceleration of the particle with time. So here, I think, correct me if I'm wrong, Yanni, but I think for the graph, you just need to pick the straight line that's going up, because Uh, yeah, because I think initially the particle is passing through the origin at one. Yeah, so I think because the graph f equals ma, so if you're relating, since f is increasing at a constant rate, a should also be increasing at a constant rate. So with a straight line, okay. So they should be increasing. Oh, okay, it's not gonna be this one because a is increasing, and then obviously not this one because it's curved. Well, this one is wrong because it's going down. I guess it should be the only correct one. Uh, I don't know what this has to. I don't like see why they, maybe for part B. But let's see part B. The velocity after 2 seconds of motion to one decimal place is what? Okay, so Sheklo they want after 2 seconds. So I guess that you're gonna use the equation v equals at plus u. And to find the acceleration, we're gonna use a is equal to f over m because f equals ma. صح? So the force after 2 seconds, I guess we just plug in 2. So 2 times minus 5 plus 4 times 2. You're gonna get 6. That's the force. The mass is 10. You're gonna get 0.6. So I guess you just do acceleration 0.6 times the time, 2 seconds, plus initial velocity 1. Get 2.2. How the fuck? Oh my god. Ya Allah. Wait. Okay. Uh, let me go through. Ya Allah. Let me go through this again, one by one. It's more advanced than I thought. بس يلا part A, I'm gonna go through it again. They want the acceleration with time. They want an expression for AT, right? They want acceleration. Well, you're gonna need it for part B as well. Acceleration is equal to force divided by mass. So basically, you put all of this over the mass. So you're gonna get 2 minus 5 plus 4t over the mass of it, which is 10 kg. So you're gonna get, cancel this with this, you're gonna get 1 over 5 minus 5 plus 4t. And I think you're supposed to distribute it inside. So you're going to get minus 1 plus 0.8 t if you substitute the one, if you distribute it inside. So this is your acceleration. Okay. وهنا it's increasing minus 1 plus 0.8 t. This means the acceleration is increasing at a constant rate. كمان, how do I know what's its initial position? Like at 0, how much is the acceleration? Substitute 0, you get minus 1 plus 0, which is minus 1. That shows that at the start it was negative and it's increasing up, right? Okay, so we found at A0, at T0, it's negative, or it's increasing because minus 1 plus 0.8t. Okay, it is the first one. هلا, we got our expression for acceleration. It's minus 1 plus 0.8t. Why this part B, I'm a bit sketched out about it because you need to use integration. Okay, most of you, I think by now you learned integration in math. This is very, very simple integration, nothing to like worry about. Okay, the velocity after 2 seconds of motion to one decimal place. You have acceleration, you want velocity. You cannot use v equals at plus u because nobody said this is for UARM, constant acceleration. Is the acceleration constant? No. So and I want to find from acceleration to velocity, I have to use integral. صح? Okay. I want velocity, so I want vt after 2 seconds. So I want v at a certain second. So vt, I need vt. How do I get vt if I have at? I don't derive. No, to go from v to a, I derive, but to go from a to v, I do the opposite of deriving. I'm sure all your math teachers taught you that the opposite of deriving is integrating. Okay, so from a to v, I integrate. Okay, so I have to find the integral of minus 1 plus 0.8 t. And this is very, very easy for those of you who don't know how to integrate. The rule of integration of x to the power of n is actually x to the power of n plus 1 over n plus 1 plus any constant. It has to be plus c. Okay, in this case, it's going to be plus v node. When you're working with acceleration velocity, always put plus the node, the initial. Okay, I'll show you in a sec. Let's integrate. Minus 1. If there's no x beside it, so if there's no variable beside it, this should be dt. That doesn't matter. But anyway, focus. If there's no variable beside, if it's just a constant number, you just take it down and add a letter beside it. Okay, easy. 0.8t is going to be 0.8t squared over 2. Why? Because it was 1 plus 1 comes 2 over 1 plus 1, which is 2. Okay, so you get this plus the constant c. This is in math, okay? But when you're working in mechanics, the constant c would be the initial value of whatever you're working. So, and I'm finding velocity, so it would be the initial value of velocity, which is actually given as 1. Okay, so you're gonna get that it's equal to minus 1t squared plus 0. Minus 1t, sorry, plus 0.4 t squared plus 1. Now substitute t with 2, you're gonna get minus 1 times 2 plus 0.4 times 2 squared is 4 plus 1, you're gonna get 2.6 minus 1, قصدي no, 1.6, yeah, minus 2, yeah, you're gonna get 0.6. Okay, it's a bit complicated. Do I think this will come? Absolutely not. But you again, please don't take my word on it. Please don't. You need to know this, okay? I think he waited until we took, because like, look, we always took the integration mechanics, but they never asked us questions about because we were never taught it in math. So I think they waited until they taught us it in math for them to actually start asking questions about it. So now you know how to integrate, so you might get this. He could ask us, okay? Uh, okay. Now let's get rid of this. Question 10. A body of mass 0.2 is initially at rest, pushed with a force of 5 for 3 seconds. What's the acceleration? Acceleration is equal to the force divided by mass. These are the petite questions we like to see. Force 5 over 0.2. You're gonna get 25. Nice. What's the final speed of the body? Okay. You have acceleration. It's 25. Right? Okay. You have the time. T equals 3. They want final speed. Okay. It's pushed with a constant force. That means the acceleration is constant. If A is constant, that means it's UARM. And if I want to find the V in UARM, I just do AT plus U. So V equals AT plus U. Therefore, it's the acceleration 25 times the time 3 plus the initially at rest, so U is 0. So you get 75. Question 11. You have two forces of magnitude 10 and 25 are exerted on a particle. The smallest horizontal net force they can exert on the particle is how much newtons? People will misunderstand the question here, but if you see the smallest horizontal net force, they're basically any. What is the smallest? What's the minimum value? Let's say you have a particle, and they're saying 10 and 25. They didn't specify any direction, so they're saying, let's say you had 25 here. Let's say you had 10 here. If you add these up, you would resolve this into component x, y, وما بعرف شو, ما بعرف شو. But when would you have the smallest value? You'd have the smallest value horizontally if you had them like this. Because when you subtract these two, you're going to get 15. If you don't trust me, I'll solve an example for you. Let's say عندك البارتكل هون 25 والتاني 10. Let's say you put it like this. Okay, وأنا بعطيك الانجل هون 60. Okay, do it. This one is 25 horizontally. This one horizontally will be minus 10 cosine 60, which is 5. Is this smaller than 15, like we found in the earlier example? No. So basically, my point that I'm trying to prove to you, the smallest horizontal net force will always be when they are in directly opposite directions. When they are in opposite directions, 25 minus 10 will be 15. The two forces are now placed to make an angle of 130 degrees between each other. What is the net force on the particle? The easiest way to draw this, حط ال 25 هون. This is actually using the same example I just said. I think, is it? I don't know. 25 وعندك هون 130 degrees. 130 degrees يعني 90 هون. 90 minus 130 minus 90 is 40 degrees. يعني هيدي 40. يعني هيدي هون 50. Okay, remember you use this one always, the one with the x-axis. So هيدي هون انت. Okay, now you can easily solve this. 25 stays 25. Okay. They want the net force. Sorry. The net force F net is equal to root fx squared plus fy squared. صح easy. طيب fx كيف نلاقيها؟ fx let's call this f1 هون f2 هون. Okay, هيدي 10 newtons هاي 25 newtons, right? طيب f1x, how will you find it? هيدي f1 هون. It's obvious it's only 25 newtons because it doesn't have any vertical component. It's just horizontally going to the right. So كمان f1y would be 0 for that same reason that I just stated. f2x هلا it's going to the left فات's negative. الفورce is 10 والانجل تبعتها cosine 50. صح. Okay. f2y however it's going up so it's gonna stay positive والفورce تبعتها 10 والانجل تبعتها 50. فهلا you take your calculator. f1x plus f2x so 25 minus 10 cosine 50. You get this 18. Let's all 18.6. So fx 18.6 والfy by the way you should put vector symbol بس أنا مالي خدمة. وfy is equal to 0 plus 10 sine 50. So 10 sine 50 7.66. So خلينا نقول 7.7. بعدين تعمل الماجنتيود بعدين radical square plus square. So 18.6 plus 7.7 to the nearest integer 20. Question 12. Okay. The figure below shows action of three forces. What's the magnitude of these resultant forces to the nearest integer? Ya Allah. Okay. Yeah, let's do it. And the cone 36.87. Okay, let's do it fast. Okay. Let's get the fx, fy. Okay. fx, it's called this f1. Okay, it's already called f1x plus f2x plus f3x. f1x is 5 cosine 36.87. صح. I won't write it, but I'll do it. You know what? Let me write. f1x is 5 cosine 36.87, which is equal to what? 5 cosine 36.87. 4. f1y would be sine now. 3. Okay, hello, these ones are easy. f2 x is 0, f2y is minus 3.0 because it's just going down, there's no left or right. وبعدين f3 كمان is an easy one because it's x is minus 4 but it has 0y. So let's add up the x's and the y's. So 4 newtons, that's f1x. f2x is 0, f3x is minus 4, so minus 4. You get 0, so fx is 0. fy is equal to, add up all the y's. 3 minus 3 plus 0, so كمان it will be أكيد 0. So if you do radical 0 squared plus 0 squared, what will you get? 0. Question 13. A spring has a constant of 50, so k is 50. How far in meters must the spring be pulled in order to produce at 75 meters? Okay. F is equal to kx. صح, force 75. K is minus kx, but let's just say عادي. They're saying distance, so we just keep it positive. So k is 50. With distance, keep it in x. So you do 75 divided by 50 to find x. You can get 1.5 meters. So you just keep it as 1.5. Okay. A block of mass 10 is sliding down a plane inclined at 37 with the horizontal. The block is sliding at a constant speed. What's the normal push exerted by the surface of the block? Okay, I'm gonna show you this. I'm gonna draw it. I'm gonna give you a formula احفظها. Okay, هي دي هون block normal push. Okay. طيب هيدي هون النورمال push وبدهم friction. If it's sliding down for friction is this way. Okay. What's the force we know acting on it? أكيد it's the weight. صح. And this is how we're gonna do it. You're gonna draw الweight. Oh, let's find it. What is it? It's equal to mg because you need this to solve. Mass 10 times g10, so 100. Okay. This is what you're gonna do. الweight هترسم حدا. You're gonna draw the horizontal like this. But you're gonna want this angle here. You should know that this angle here is 90 minus this angle here. I think, wait, هيدي 90 هون. Yeah, okay, I don't know what I was saying now. But you should know this angle here is equal to 90 minus the angle you have down here. With the horizontal is 37. They said it's 37. Okay, so you're gonna get 53 degrees. So هيدي هون 53 degrees. Okay, here's what you do. I can give you a formula. Now I'm gonna give you a formula where you don't have to do any of this. You can just apply it numbers in a calculator. Okay, the force of friction is equal to the actual force we have. That's 100. And since it's horizontally, it's cosine 53, if I'm not wrong. Let me just see, because I feel like I'm doing something wrong. Yeah, why did I start with friction? Yeah, I should start with normal push. The normal push is going vertically. It's 100 sine 53. So friction لقيناها at 60. والnormal push 80. Walid, do you have a formula you can give me straight away so I don't have to draw and do all of this stuff? You can memorize this formula. Normal push when you're speaking about inclined plane. Okay, it works all the time. Normal force is equal to the force or weight. Let's call it weight because the force we have now is weight. Weight cosine theta, and the friction force is equal to the weight sine theta. You say, well, you keep sine, keep cosine, mad. This is where theta is the angle with the horizontal of the inclined plane. Okay, this is only for this case. But if you decided to do 90 minus 37, or for some reason they gave you this angle here, then you would switch these with cosine and sine. But that never happens. So they give you 99% of the time the angle with the horizontal. You want the normal, you do weight cosine theta, like I can show you. The weight is 100 cosine 37 بيطلع لك 80 for the normal push. Oh, same thing, 100 sine 37 is around 60. Okay. Okay. Two springs of stiffness 150 are, so this is stiffness, and this is their K. Okay. They're hanging side by side. A box of mass 3 is attached to both of them. G is 10. What is the equivalent stiffness of the spring? أكيد if they're two identical springs وكل واحدة 150, 150 here, 150 here, أكيد ال equivalent 150, 150 بيطلع لك 300. What is the extension? Okay. You need to know أول شيء what's the force. أنت you're hanging a box of mass 3 kilograms. What's the force when you're talking about weight? Masses وهيك? It's weight. يعني 3 times G, which is 10, which is 30. So the weight is 30 newtons. Or that's the force acting downwards. What did we know about the extension? It's equal to minus kx. And سهل in minus for now, just do kx. Okay. طيب الفورس هي 30. الk هي قلنا 300. والx is elongation we're trying to find. So x أكيد will be 30 over 300, which is 0.1. But remember this answer is in meters. based on centimeters. So what do you do? Times 100, which is 10 centimeters. Okay. Question 16. This one very easy. You have to put the free body diagrams. You should know this. An airplane in air is increasing its altitude while moving uniformly forward. If it's increasing its altitude, yani it's going up uniformly forward, yani the front and the back cancel each other out. Okay, a block of wood is resting on a rough inclined plane. If it's resting, I don't agree with this, صراحة. Never mind. Because they said rough inclined plane. Rough inclined plane, يعني في friction, أكيد because it's rough, opposing it backwards. أكيد since it's resting on a rough inclined plane, it's resting at all, they will always be normal, always be weight. Okay, so this will make sense. A block attached to a rope is lowered down at a constant acceleration. If it's on a rope, يعني عندك الweight وعندك الtension force. A trolley is pushed across a rough horizontal floor with an increasing speed. هلا rough horizontal floor يعني في friction, but you should know that the speed is increasing. يعني one side of the horizontal will be larger than the other side of the horizontal. أكيد you always have weight to normal. Okay, I hope you understood. Thank you so much for watching and good luck.